All right, going back to problem 7. We wrote our explicit form, and we were working on the recursive. So we said that our recursive was a1 equals whatever our first value is, and then we have an equals an minus 1 plus d. So we said that a1 equals 18. Our first term in our sequence is 18. So then again, writing this generally, we have an, because we're not finding a specific term, so we leave that as an. That equals the previous term, so still an minus 1. And then add your d value. And your d value, we were adding 8. So we add 8. So for this one, the only thing that we're putting in is that plus 8 and our a1. So you're leaving those in like a general form, just using the numbers that you're provided in the sequence. Number 8, we need to find the two missing terms. We can do this two different ways. You can do this using the slide method, so we're going to label each of our points, or each of our terms. So we have A1, we're looking for A2, A3, and we have A4. We need to find our common difference in order to solve this. So you can either set it up as 2 points, because these are a linear relationship, so we can have 1, 3, and then 4, 21. And then you would take the slide, you've got 3 minus 21 over 1 minus 4. So you get negative 18 over negative 3, which gives you a 6. So that tells you that your common difference is 6. So 3 plus 6 gives you 9. 9 plus 6 gives you 15. And then 15 plus 6 would give you that 21. You can also set it up using the explicit formula. So an equals a1 plus n minus 1 times d. And this time you're solving for that d value. So you're going to use the numbers that you're provided with. So we're going to set an equal to our fourth value. So we're going to have a4 equals a1. If our n is 4, we have 4 minus 1 here. And then again, we're looking for that d value. So plugging in the values that we have, a4 is 21. That equals 3 plus, when you simplify 4 minus 1, you get 3. So plus 3d. Solving for d, we're going to subtract that 3. So we're going to get 18 equals 3d. Divide by 3, 6 equals d. So you get the same common difference, whichever way you choose to do it. And then you'll get 9 and 15. So number 8 should be 9 and 15. Now on to the back. Number 9. Number 9, we're just looking for that one middle value. So that's when we can use the arithmetic mean, which was if we took 5 plus 21 and divided by 2. So we get 26 divided by 2, which equals 13. So that actually gives us this middle value. So this middle value is 13. So 19, or 9, number 9 is 13. Number 10, we're going to do the same thing that we did in number 9 to find those two middle terms. So if we do the slide, you're going to have 1, 65, 4, 32. You're going to have 65 minus 32 divided by 1 minus 4. So you get negative 33 divided by, or positive 33, sorry, divided by negative 3. So you're going to get negative 11 when you divide that out. So your common difference is negative 11. So we're subtracting 11 each time. So 65 minus 11 is 54. 54 minus 11 is 43. And then that 43 minus 11 will give you that 32. So that's how you check to see if you have that right. So number 10, you should have 54 and 43. Or you can also use the explicit formula like we just did in example 8. For number 11, we need to find the 7th term of the geometric sequence. So we're already told that this is a geometric sequence. So we're going to use an equals a1 times r to the n minus 1. That was our explicit formula for the geometric sequence. So we're finding a7. That equals our first value, which is negative 3, times our r value. Our r value, we're going from negative 3 to 9, so we're multiplying by negative 3. So our r value is going to be negative 3, and that's going to be to the 7 minus 1 power. Now, for this one, make sure this negative 3, when you plug it into your calculator, that it's in parentheses. You need to take this negative 3, the whole quantity, to the 6th power. You're going to have negative 3 times negative 3 to the 6th. And when you multiply that out, you should get negative 2,187. So number 11, you should get negative 2,187. For number 12, we're finding the 7th term for this one as well. So we need a7 equals our first term, which is 1, times our r value. This time, we're multiplying by a third each time. So our r value here is 1/3. So we're taking 1/3 to the 7 minus 1 power. So this equals 1 times 1/3 to the 6th. When you plug that into your calculator, you should get 1 over 729. So number 12 is 1 over 729. Number 13, we're asked to write the explicit formula and then find the first 5 terms. Writing the explicit formula is just going to be like writing the explicit formula for the arithmetic ones, except now we're using the geometric. So again, our formula was an equals a1 times r to the n minus 1. So we're told that we have a1 equals 32 and r equals 0.5. So our explicit formula, not looking for a specific term, is an equals our a1 is 32 times our r value, which was 0.5, to the n minus 1. Again, we're not looking for a specific term, we're just writing this in terms generally. So now we need to find the first 5 terms. So that means we need to find a1, a2, a3, a4, and a5. We can either use the explicit formula or we can just use the pattern. So we're automatically given a1. a1 is 32. They gave us that. In a geometric sequence, remember to get from one term to the next. So from our first term to our second term, we're multiplying by our r value. So we're having 32 times 0.5, which is going to give us 16. 16 times 0.5 gives us 8. 8 times 0.5 is 4. 4 times 0.5 is 2. But you also can use the explicit formula for each one of those. You can plug in your n values. Number 14 is doing the exact same thing. except this time we're given different values over here. So again, we have an equals a1 times r to the n minus 1. Plug in the values you know. So an equals, our a1 value is 8, times our r value is -1, and that is again to the n minus 1 power. Now to find our first 5 terms, you're given a1 again. So you already know that your first term is 8. Now for each term we're multiplying by -1. So 8 times -1 is -8. -8 times -1 is 8. 8 times -1 is -8. And then -8 times -1 is 8 again. So this is very much like number 4 on the front, where we're just multiplying by -1 each time. Number 15, we want to find that middle value. For a geometric sequence, to find that middle value when we're only looking for 1, we use the square root of x times y. So we can call 12x and 3y, so we're going to take the square root of 12 times 3. This ends up equaling the square root of 36. And then remember, when you square root this, you're going to get positive or -6. Because we're multiplying, you can get either positive or negative. We're not given enough information in this sequence to tell whether it's going to be positive or negative. So you should have positive or -6. For number 15, we're finding the two middle terms. So this is when we're going to use our explicit formula again for a geometric sequence. So we have an equals a1 times r to the n minus 1. Plugging in again the values that we know. We have a1 and we have a4. We're looking for a2 and a3. So we have to find our r value. We have to find that common ratio. So we're going to set an equal to a4. That's going to equal our a1 value times r to the 4 minus 1 power. So now actually plug in your values. So we're going to have 128 equals 2 times r to the third, because 4 minus 1 is 3. To solve for r, we're going to divide by 2. So we're going to get 64 equals r cubed. Then we're going to cube root both sides. And we're going to get that r equals 4. So, to get from our first term to our second term, we're going to multiply by that 4. So we're going to get 8. 8 times 4 is 32. And then 32 times 4 gives us that 128. So you should get 8 and 32. And then our final problem, the story problem. It says that a movie theater has 24 seats in the first row, 29 in the second row, 34 in the third, and so on. There are 44 rows in the theater. How many seats are in the 44th row? So write down the numbers that you're given. You're told in the first row you have 24. In the second row you have 29. In the third row you have 34. Find the pattern between these numbers. So to get from 24 to 29, we're adding 5. 29 to 34, we're adding 5. So this is going to be an arithmetic sequence. And we want to find how many seats are in the 44th row. So write your explicit formula, an equals a1 plus n minus 1 times d. Our an this time we're looking for the 44th row, so we're looking for a4. 44. That equals our first term, was how many seats were in the first row? We had 24. Plus, our n value is at 44, so 44 minus 1. And then our d value is this plus 5, so we're multiplying by 5. So then, solving this, we have 24 plus 43 times 5. Remember to multiply this 43 and 5 first, and then add the 24. And you should get 239. So there are 239 seats in row 44. And that is the end of the partner test. Remember that you also need to know the formulas for tomorrow, the recursive and the explicit, for both arithmetic and geometric sequences.